triangles congruent. So before we can prove triangles congruent, we're going to understand what it means for any figure to be congruent. Congruent figures have the same size and shape. This is below the box there on your notes. Congruent figures have the same size and shape. So if I had two hearts that were exactly the same size, they would be congruent. If I had two squares exactly the same size, they would be congruent figures. Two ovals, congruent figures. If you copy and paste on the computer, those would be congruent figures. Same size, same shape. I know him. Now that's stuck in your head. It's stuck in your head. Should I ask him to sing it and send it to us? Okay, I will. Do it afterwards. That's funny. Congruent polygons. Polygons that have corresponding sides congruent and corresponding angles congruent. They're basically the same definition, but polygons have congruent corresponding sides and congruent corresponding angles. Corresponding, the sides that are on the same part of the polygon. Angles, the same angles in the polygons, like they line up together. Why there's two definitions? Because there's a difference between a figure and a polygon. Last chapter we said a polygon is made up of only segments, meaning there's no curves. Figures can have curves, so you can have congruent ovals and hearts and circles. Those are still considered to be figures. Difference? Women. They have a figure. Women have curves. That's how I remember it. Figures and curves go together. Polygons, nothing. They're all segments. Sure. So, you don't have these two triangles on your notes, but looking at all their markings, we can say, anyway, looking at the markings, you can see that DE is congruent to HG. They both have one tick mark. EF is congruent to HI. They both have two tick marks. FD is congruent to GI. They both have three. So the corresponding ticks match up which sides are congruent. Same with angles. D and G, they each have one. E and H, they each have two. And then F and I, they each have three. Since all their parts are congruent, their corresponding sides and corresponding angles, I would say that these two triangles are congruent. And when I'm saying corresponding sides, like EF, my smallest side is congruent to HI, the smallest side. Since they're both the smallest sides, that makes them corresponding. Or the biggest angles, E and H, they're both the biggest, so they're corresponding angles and they're congruent. Okay? That corresponding still refers to like the same position in relation to the figure. Over here, I have triangle blank is congruent to triangle blank. This is a congruency statement. That's what it's called. When you write a congruency statement, you just name the first triangle based off of the vertices. So what could we name the first triangle? DEF. Good. So we're going to say triangle DEF is congruent to, this is where it becomes important. You have to make sure the corresponding parts line up. So since D comes first, the angle that's congruent to D needs to come first over here. Which angle is congruent to D? G. How about angle E? H, and then I. So in your congruency statement, your congruent angles should line up. No matter if you have 3 because it's a triangle or if you have 8 because it's an octagon, the congruent angles should be in the same position. Okay, congruency statement. Cool. Just gonna skip this here. To number 1. Using this congruency statement in your picture, let's list the congruent corresponding parts. I forgot your Q. It's the vertice that's not there on the triangle. You want that there on the second triangle. My triangles aren't going to look just like yours, but that's going to be okay. Okay. Congruency statements. They have a lot of information in it. It tells you which angles are congruent and which sides are congruent. Angle A, since it comes first, would be congruent to which angle? Q, because they're both in the first spot. And you can mark that on your paper. Angle A is congruent to angle Q. But then you also have to list it, because it says list the congruent corresponding parts. Using the congruency statement. Angle B would be congruent to which angle? T, because they're both in the middle on the congruency statement. Mark it. When you mark it, make sure you use a different set of curves, and then list it. Angle B is congruent to angle T. And then lastly, angle C is congruent to angle J. So there are your three angles. But a triangle is also made up of sides, so we have to list the three pairs of sides that are congruent. Oh. AB, the first two letters of the congruency statement, are congruent to QT, the first two letters. Those first two letters make up side AB and then side QT. So then we'll list AB is congruent to QT. The second two letters, BC, corresponds with the second two letters of the next one, TJ. BC is congruent to TJ. And looking at the picture, it's easy to see what sides left out, AC and QJ. But if you didn't have a picture, your third side on the congruency statement comes from the first and the last letter. AC is congruent to QJ. Okay, so pictures should be there to help you. The congruency statement will give you all the answers, but don't be afraid to draw a picture and use both of them together so you get it right. Since it says list them, then you should list 6 pairs of information. If I gave you 2 quads and told you to list all corresponding parts, then you should have 8 pairs. 4 pairs of angles, 4 pairs of sides. Okay? Let's back up here a second. And right now we know that A is congruent to Q and B is congruent to T. And let's just pretend that angle A is 40 degrees. Therefore, angle Q would have to be, okay? And let's pretend that B is 60 degrees. Then angle T would have to be, how would I find angle C? Triangle sum theorem, which says all 3 angles have to add up to what? Good. What's 40 plus 60? What's 180 minus 100? 80. Using the triangle sum theorem on my second triangle, 40 plus 60, subtracted from 180, 80. 2 angles, A and B, congruent to 2 angles of another triangle, Q and T, then the third angles have to be congruent. That's your theorem above that. If 2 angles of one triangle, A and B, are congruent to 2 angles of another triangle, E and D, then the third angles have to be congruent, branching off your triangle sum theorem. Does that make sense how I just showed you on the other triangle? Yeah, Micah? Okay. So in your little blanks here, we'll say angle C is congruent to angle F. 2 angles of one triangle congruent to 2 angles of another triangle makes the third angles congruent. Good deal. So number 2. Triangle XYZ is congruent to triangle KLM. The measure of angle Y equals 67 and the measure of angle M equals 48. Find the measure of angle X. Use the triangle angle sum theorem and the definition of congruent polygons to find the measure of angle X. If you don't know where to start with a picture. Draw 2 triangles. They don't have to be perfect. I mean, you can make them look exactly the same. We probably should since it says they're congruent, but it doesn't matter. And then just put your ABC and XYZs around there. And they tell me, oh, I didn't even need ABC. Geez, Carol. Sorry. KLM. Apparently I thought we needed to use other parts of the alphabet. Y is 67. M is 48. And we're trying to find the measure of angle X. So put a little angle X there. What do you think? Any thoughts on how we can do this? Zach? Triangle angle sum theorem? How so? How do you know M is congruent to Z? Because of what? I just didn't hear you. Yeah, because of the congruency statement. Good. In the very first part of this whole problem, triangle XYZ congruent to KLM, tells us which angles are congruent and which sides are congruent by the order of where they're listed. Angle Z, since it's last, would be congruent to angle M, since that one's last. So M congruent to Z means that Z has to be what measurement? 48. And now in this triangle, I know 2 of my 3, and we know that all 3 of them have to add up to what? 180. So 67 plus 48, 115. And then subtract that from 180. What do we get? 65. Good. So we really used the definition of congruent polygons first, and then used our triangle angle sum theorem. Kendra, since angle X is 65 degrees, how would you classify this triangle based on its angles? Good job. Are we good on 3, 2? Okay, number 3 then. Can you conclude that triangle ABC is congruent to triangle EDC? Put in there this statement, I forgot to write it on there for you, that C is the midpoint of AE. C is the midpoint of segment AE. See? You heard it again, didn't you? Glad to know I wasn't going crazy. Let's stop bringing the answer. Oh. Okay. Okay, so for any polygons to be figured, triangles, squares, rectangles, whatever, you have to show or prove or explain that all corresponding parts are congruent. So since we're looking at triangles, we need to show that all 3 sides of one triangle are congruent to all 3 sides of the other triangle, and all 3 angles of the one triangle are congruent to all 3 angles of the other triangle. Because you have to explain or show or somehow, whatever, get through that all 6 things are congruent. Just start with one. Do you want to look at the sides first, or do you want to look at the angles first? Angles? Okay. So if we look at the angles of each triangle, they've already marked angle A congruent to angle E. There's one pair. Would B and D be congruent? Sure, because they're both right angles, right? Okay, how about the third pair of angles? Why are they congruent? Yeah, because of the vertical angles theorem. So just mark them congruent. If you want to write because they're vertical, you can do that, but I think we all got that. So we have all 3 pairs of angles congruent. Now we need to check the sides. The little 3 and 4 on the outside, those are the side lengths. So they're telling us that BA has a length of 3 and DE has a length of 3. Well, if they both have a length of 3, what can you tell me about those segments? They're congruent. Put little congruent marks on them. BC is 4 and DC is 4. So what do we know about those 2 segments? They're congruent. Now we have to decide if AC is congruent to EC. Yeah, right here, this thing I made you add. Since C is the midpoint of segment AE, C is right in the middle of them. Therefore, the left side must be congruent there to the right side. So would you say that these triangles are congruent? Yes, you can. Can you conclude? Yep. I'm just going to add on here all corresponding angles and sides are congruent. Sometimes it'll make you justify it, so I'm just going to justify them each time. So we've got to show that all parts are congruent. After you have that copied down, go ahead and flip it over. Excuse me. And do number 4. It says list the congruent corresponding parts. Yours also says to use 3 letters when naming the angles. Just cross that sentence off. 6. Can you conclude that triangle JKL is congruent to triangle MNL? Justify your answer. What are you looking for? What do you guys have to look for in order to decide if triangles can be congruent or not right now? What about the angles? That what? Congruent sides and angles. One from each triangle. So pick one thing to look at first. You want to look at the angles first or the sides first? The sides first? Okay, what do you got, Bree? Good. If I look at segment KL, because it has a tick mark in it, the tick mark doesn't correspond with any side in the other triangle. It's just corresponding to the same triangle. So since KL isn't congruent to any side over here, triangles can't be congruent because I don't have corresponding sides congruent. There you go. Done. Can you conclude? No. Justify your answer. Corresponding sides are not congruent. Then you really didn't even have to look at the angles since the sides didn't work. Had you started with the angles, they actually all would have worked out. If you've got vertical angles, that would have worked. Nope, because you would have confirmed that all the angles are congruent, but the sides still wouldn't have been congruent, so then the triangles aren't congruent. Does that make sense? Okay. All right. Chapter 4 has proofs. You already have some on your homework today, so we're just going to jump right back into them. We have a bunch of information in the given, and then we're trying to prove that the 2 triangles are congruent. What's your first step with a proof? Write your given down. You may want to try and write small on this one. Just an FYI. I didn't get your G printed on, but G is the top angle there of the big triangle. After you write your given, what should we do? Alyssa? You should mark your picture. Yep, for sure. Mark it based off of the given. It's going to become completely and like utterly insane if you don't mark it in this chapter, because marking your picture half the time gives you your answers. So mark it. CG congruent to DG. CN is congruent to DN. Make sure you use different sets there. Angle C is congruent to angle D. And then it says GN is perpendicular to CD. What does that mean again? They form a right angle. Where they intersect? At what vertex or what point do they intersect at? N. Good. So you can put a right angle in there. You can put one on each side if you want 2 of them. You don't have to. You can just put one down too. So they want us to prove then that triangle CNG, that's the little one on the left, is congruent to triangle DNG, the little one on the right. What do we have to justify or explain or put in our proofs in order for these triangles to be congruent? What do we have to make sure we have? Congruent sides and angles. We have to make sure that all 3 pairs of angles are listed congruent in your steps. You have to make sure that all 3 pairs of sides are listed congruent in your steps. Looking at the given, we have 1 pair of sides, CG and DG, and the second pair of sides, CN and DN. Well, what is the third side of triangle CNG? That's not marked yet. GN. What's the third side of triangle DNG that isn't marked yet? GN. So they both use GN. So would it be congruent to itself then? Wouldn't it? It's the same segment. So we can say that GN is congruent to GN. And mark it. Mark that in your picture after you write it down. Got to come up with a reason for this. This goes way back to chapter 2. It's one of our properties. It's like it's looking in the mirror. What do you see when you look in a mirror? Your reflection. This is your reflexive property. He'll come back and hang out with us in this chapter a lot. What's that called? Personification, giving a non-human object human qualities, right? Okay. They both said sure. So we have all three sides listed. So now we have to make sure we have all three pairs of angles congruent and listed in the proof. Oh, not the crayon. Our given gave us one pair of angles, C and D. We have to decide, prove that the other pairs of angles are congruent. What do you think? You know if any of them are congruent? Which ones? Why are those two angles congruent? They're both right angles? Would you agree with him? Why are they both right angles? Because the lines are perpendicular. You were right. Yeah. So since these two lines are perpendicular, I get two right angles. Since they're both right angles, would they be congruent? Shake your head, yes. Okay. Right? Because what's the measure of a right angle? 90. And if two angles equal 90, aren't they congruent? Okay, we have to do this in 2 steps. Your first of the 2 steps, step 3. Well, I'm going to leave this to you. Do you want to say that they're right angles, or do you want to say that they equal 90 degrees? It doesn't matter, you pick. That they equal 90? Okay, so then we need to write that the measure of angle CNG, you have to use 3 letters here, and remember the vertex is the middle letter, equals 90, comma, the measure of angle DNG equals 90. How do we know that? How do we know they were 90-degree angles? How do we know they were right angles? Because the perpendicular lines. Definition of perpendicular lines. Since they both equal 90, then the angles must be what? Congruent. Good. So then on step 4, we can say angle CNG is congruent to angle DNG. And this would be the definition of congruent angles. So you first have to tell me that they equal 90 degrees before you can tell me that they're congruent. Because the given only tells us that the lines were perpendicular. It didn't specifically talk about each angle. So we have 2 of the 3. We have to figure out if that third pair of angles are congruent. We know that these guys are. No, I'm not there yet. We just said that the angles are congruent. Yeah, so I'm trying to figure out if these top 2 angles, these little guys, would be congruent. Let's play a game. We already said that these are 90. Let's say that C is 60. What's D going to be? So what's that leave for these 2 top guys? 30. Each would be 30. Let's play another game. They're still 90 because of the perpendicular lines. Let's pretend that C is 70. What would D have to be? So what are these 2 going to be? 20 each. If I pick another number, will they come out to be congruent? Why? Because of the 4.1 theorem, Lindsay, right? Yeah, what's that theorem say? Exactly. We're using that first theorem. Flip it over for me. Do you see how it says theorem 4.1? Does it have a name behind it? Then you have to write it all out. No, because then I'm going to say, what's theorem 3.7? Exactly. So what we're going to write then, number 5. Angle CGN is congruent to angle DGN. Now I put my G's in the middle because we're talking about that vertex. Reason this is about the smallest I can make it. If two angles of one triangle are congruent to two angles of another, comma, third angles congruent. Two angles of one triangle are congruent to two angles of another, comma, third angles are congruent. My comma is replacing the word then. I have my word if. So now we have the third pair of angles. And if you go back and look at my highlighting, in yellow are the 3 pairs of sides, in green are the 3 pairs of angles. Since we have proved and listed that all corresponding parts are congruent, then we conclude that the triangles are congruent. So step 6, you're copying exactly what's behind the word prove. Triangle CNG is congruent to triangle DNG. And this is going to be by the definition of congruent polygons. They're not all going to be 6 steps. Some might be shorter, some might be longer. Just kind of depends. Once you have step 6 copied down, start doing your given for the next proof. And I think the C and D didn't copy over very well on your picture. The C is the top one on the right side. Sorry, I failed you a couple times on this notes today. After you write your given, what should we do with that information? Mark your picture, good. Angle A congruent to angle D. Angle E is congruent to angle C. AE is congruent to DC. EB is congruent to CB. And BA is congruent to BD. We're trying to prove that the 2 triangles are congruent, which means we have to have 6 things for sure listed in your proof. Not 6 statements, but 6 things listed, that all 3 pairs of angles are congruent and all 3 pairs of sides are congruent. In my given, 1 side, 2 sides, 3 sides. They already gave me all 3 sides. In my given, 1, 2. They gave me 2 of the 3 angles. What's the third angles that we haven't marked yet? Good, ABE and CDB. What kind of angles are they? Which means they have to be what? Awesome. So on step 2, angle ABE is congruent to angle DBC by your vertical angle theorem. Make sure anytime you have vertical angles, you're using 3 letters to name it. If you said angle B, there's technically, anytime you have vertical angles, you should use 3 letters. Sorry. That was your third pair of angles. So step 3, we're done. Angle AEB is congruent, triangle AEB is congruent to triangle DCB by the definition of congruent polygons. That wasn't so bad, was it? It's nice sometimes when they give you a lot of information in the given.